So, first video for unit number 2, we're going to talk about patterns and sequences. Please make sure that you take very good and detailed notes and that you are prepared to ask questions tomorrow, because while this is something you've seen before, some of these questions can get pretty difficult, and so you need to be prepared not only to ask questions but also to think when you come to class tomorrow. So make sure you have everything you need for that. So let's start. Okay, we want to come up with a table and a function rule for this picture right here. Well, if this is figure 1, this is figure 2, and this is figure 3, my table looks like this. This is figure number, and this is the number of blocks for that figure number. And so figure number 1, you can count, it has 8 blocks. Then figure number 2 has those 8 blocks plus 2 more. So figure number 2 has 10 blocks. Figure number 3 has those 10 blocks plus 2 more. So figure number 3 has 12 blocks. And we could go on this pattern all day long, so hopefully you have realized that every time I go to the next figure number, I add 2 blocks. And I would keep adding 2 as I went through this pattern. If I wanted to continue on, I would keep going plus 2, plus 2, plus 2. And if you'll remember from elementary school, repeated addition of the same number is the same thing as multiplying by that number. So my pattern rule is going to start with 2 times n, where n represents the figure or the term number. Now, to see if there's anything else that has to go on with my rule here, I'm going to test this 2 times n with what I've been given. So if I do 2 times 1, that equals 2, but I know from my table that what I need it to equal is 8. So in order to make that work, I'm going to have to add 6, because 2 times 1 is 2, plus 6 gives me 8. And then if you check it again, 2 times 2 is 4, plus 6 equals 10. So here is my rule. So the next question says, determine the total number of blocks whenever the term number is 8. Well, they want to know how many blocks are there when n equals 8. So you plug in 8, and you just do the math. So you have 16 plus 6. There are 22 blocks for term number 8. Part C is the exact same thing. It says, or it's the opposite. It says, what will the term number be whenever there are 52 blocks? Well, now they're asking you to find n if you know that it equals 52. So you have an equation you can solve. If you subtract 6 on both sides, you end up with 2n is equal to 46. And then when you divide by 2 on both sides, you get that n equals 23. So the 23rd figure has 52 blocks. So there's our first pattern. Let's move on. We're going to do another pattern, but this time we're going to go from a scatter plot to a table to a function rule. So when we go from the scatter plot to the table, we have x values and y values because we have points on a graph. And we're going to look at this graph from the furthest left point to the furthest right point. We'll always go left to right. And we're just going to list out the ordered pairs. Just in case you cannot read these numbers, since they are kind of blurry, each one of these lines is 1 unit. So it's 1, 2, 3, 4. So you just count them. So this first point right here, x is 2 and y is 11. And then the next point right here, x is 5. My bad, x is 4 and y equals 5. And then this point right here, x is 5 and y equals 2. And this one way over here, x is 8, y is negative 7. So in order to come up with our function rule, we first have to be able to establish a pattern. So we have got to figure out what our change is over here for every change in 1 over here. So I need it to be, how much does it change for every 1 unit? So what I have right now is right here from 11 to 5, I have a change of negative 6, because from 11 to 5 is getting smaller, I'm decreasing. So I have a decrease of 6 for a change in 2. Well, if I decrease 6 for every 2, doesn't that mean that I decrease negative 3 for every 1? All I did was simplify this. Negative 6 over 2 is the same as negative 3 over 1. So it should be a change of a decrease in 3 for every 1. So let's look one more. My decrease here is negative 3 for 1 unit change here. So my function rule is going to start with my change for every 1 unit, which is a decrease in 3. I'm going to use x instead of n this time because I have an x and a y going on, and those are my variables. Now let's test it to see if I need to do anything else. So negative 3 times 2 gives me negative 6. But I need a positive 11. So in order for that to happen, I need to add 17. Okay, to get from a negative 6 to a positive 11, I have to add 17 for that to work. So here is my function rule, or my rule for my thing. So now they want us to determine what y equals when the x value is 12. Well, that just means I get to plug in 12 for x and then do the math. Well, negative 3 plus 12, that's negative 36 plus 17, which gives you negative 19. So y equals negative 19 when x is 12. But let's go backwards. Now they ask for the x value if the y value is negative 61. Well, here's my function rule. And I know I want it to equal negative 61. So now I have an equation that I can solve. I start by subtracting 17 on both sides. And so I have negative 3x is equal to negative 78. And then I'm going to divide by negative 3 on both sides. And get that x is 26. So when x is 26, y is negative 61, and I could turn that into an ordered pair and plot that point on my graph. But that's what they're asking for, so that's my answer. So let's do one more like this, except now we're going to go from a sequence to a table to a rule. So here is my sequence, and in my sequence I have first, second, third, and fourth number. So what I have is my term number and whatever the value of that is. Well, term number 1 is 18. Term number 2 is 23.5. Term number 3 is 29. And term number 4 is 34.5. So we're going to start by finding our change. So my change from here to here is an increase in by 5.5 for a change in 1, which is what I want. So let's make sure it stays the same. From here to here is 5.5 for a change of 1. So my function rule is going to start with 5.5n. And then I'm going to test it. If I do 5.5 times 1, I get 5.5, but I need that to equal 18. So in order for that to happen, I have to add 12.5. So 5.5 times 1 is 5.5, plus 12.5 is going to be 18. And so that's where my function rule came from. So now let's use a rule. So if n represents a number's position in a sequence, meaning is it the first number, the second number, the third number, then they want us to write the first 5 terms described by each expression. Let's do this one over here on the right. If I want the first number in this sequence, I want n to be 1. So I'm going to plug in 1 for n, and then I'm just going to calculate out what it equals. Well, 1 minus 1.5 is negative 0.5, so I have 1 times negative 0.5 plus 2. Well, anything times 1 is just itself, so I have negative 0.5 plus 2, which is 1.5. So the first term in this sequence is 1.5. The next term in this sequence would be the second term, and in order to get that, I would plug in 2. So I would do 2 times 2 minus 1.5 plus 2. Well, 2 minus 1.5 is going to be 0.5. And so now I have 2 times positive 0.5 plus 2. Well, 2 times 0.5 is a whole. So now I have 1 plus 2. And so the next term in my sequence is 3. Because 1 plus 2 is 3. If I wanted the third term in my sequence, I would plug in the number 3 and do the same thing. If I wanted the 20th term in the sequence, I would plug in the number 20. You need to finish this and write for me the next 3 terms of this sequence, because it does ask for the first 5. So on your paper, I need you to find the next 3 terms doing the same thing. So you want to find 3, 4, and 5, and then make sure you write them down. So let's do another one here. I have a train is moving at a constant rate of speed, which tells me that its speed is not increasing or decreasing. It's going the same rate the whole time. And this table shows how far it travels in a given number of minutes. We're supposed to use the information to determine how many miles the train will travel in 45 minutes and write a rule. We're going to write a rule before we determine 45 minutes. Let's find our change first. If this is X and this is Y, our change from here to here, from 5.75 to 11.5, is a change of 5.75. But that is for 5 minutes. What I really need is my change for 1 minute. So in order to determine that, I can divide my distance by my time. So I went this far in 5 minutes. So it's a change of 1.15 for every one. Let's test it, make sure it stays. My change for here is also 5.75 in 5 minutes, which, as we just tested here, is a change of 1.15 for every minute. Now I have to test this because I've got to figure out what else has to be added or subtracted. So let's plug in 5. So if I do 1.15 times 5, that equals exactly 5.75. So I do not have to add anything to this. This is my function rule right here. It's 1.15x because my train is going 1.15 miles per minute because this is in minutes, not in hours. So to figure out how far it's going to go in 45 minutes, I'm just going to plug in x. I'm going to plug in 45 for x. I'm going to do 1.15 times 45. And I get that the train goes 51.75 miles in 45 minutes. And so I found my function rule and then used my function rule to answer the question. Let's do a couple more. We have this picture right here. These figures have a repeating pattern. We want to figure out what is the 34th figure in this pattern. So this is figure 1, 2, 3, 4, 5, and then it repeats. And so figure 7 will be like figure 2. Figure 3 will be, okay, so then it starts to repeat. So I have 1, 2, 3, 4. It repeats every 5. Okay? So every 5 figures is going to be the same. So figure 10 is going to look like figure 5. Figure 15 is going to look like figure 5. Figure 30 is going to look like figure 5. Figure 35 is also going to look like figure 5 because it's a multiple of 5. Every multiple of 5 is going to look just like figure 5. But figure 34 is one less than a multiple of 5. So figure 34 should look like figure 4. And so my answer should be B. Now there is another way to do this, and here is how we're going to test it. I know that every 5 it changes. So if I do 34 divided by 5, and you're going to have to do this long division ways or this doesn't work. I know that 5 goes into 34 6 times. That's 30. Well, I have 4 left over. Do not try to turn this into a decimal. What you have is 6, remainder 4. It's like 4th grade division. You do the long division and you leave the remainder. You probably haven't done this since elementary school, but that's what it is. This remainder of 4 tells you how many figures to go to figure out what the 34th one is going to be. And so it's 1, 2, 3, 4. It's that one right there. Okay? We'll do another one like this tomorrow, but I wanted you to see it. It's a very good question. It's a very big SAT kind of question. Last one. In the sequence above, the first term is 1, and each term after is 2 more than twice the previous term. Well, let's write that down. It's 2 more than 2 times the one before it. If n is going to be the one before it, that's what we'll call it. We want to find out what t equals. Well, what is the term before t? The one before t is 10. So if I use this, it's 2 more than 2 times 10, which is 22. So t right here should be 22. So that is patterns and sequences. Make sure you have notes and are ready to ask questions tomorrow.